Trigonometry, Chapter 1, Trigonometric Functions, Section 4, Using Definitions of Trig Functions, Video 8, Finding all trig values given one value in a quadrant. This series is based on content from Pearson's Trigonometry, 12th edition, by Lial, Hornsby, Schneider, and Daniels. In the previous videos, we discussed the domains and ranges of all 6 trig functions. In this video, we explore how to calculate all trig functions' values when we only know one trig function's value and the quadrant of the angle. For example, suppose theta is in quadrant 4 and cosine of theta is equal to 2/3. Find the values of the remaining trig functions. Before we start, it should be mentioned that this problem can be viewed both algebraically in terms of x, y, and r, and geometrically in terms of a picture. This solution will incorporate elements of both. For most trig problems, a good drawing will help visualize the situation and perhaps give insight towards a solution. Thus, let's draw a picture illustrating the given information. To do this, we will view the given value, 2/3, as its correct ratio. Because cosine of theta is equal to x over r, we can assign values of x equals 2 and r equals 3. And here's a drawing of this information in quadrant 4. Notice we have an angle in quadrant 4, x equals 2, r equals 3. To find the remaining trig functions, we must first find y. Since x squared plus y squared equals r squared, this should be straightforward, which is actually one word. Using x equals 2 and r equals 3, we get 2 squared plus y squared equals 3 squared. So we solve this. Square the numbers to get 4 plus y squared equals 9. Subtract 4 from both sides to get y squared equals 5. And then here's where some people make a mistake. Algebraically, we square root both sides. Take the square root of both sides to cancel the square. However, algebraically, when you square root both sides of an equation, you use a plus minus on one side, usually the numerical side. In this case, cancel the square and put a plus minus in front of the square root of 5, algebraically. But when solving trig problems, you must always be aware of the quadrant you might be in. In this case, we are in quadrant 4. And in quadrant 4, x is greater than 0 and y is less than 0. Thus, the correct value of y is negative square root of 5 only, which we'll put on our picture. Now that we have x equals 2 and y equals negative square root of 5 and r equals 3, calculating all trig functions is straightforward, which I spelled as one word this time. Here's our definitions, which you should have memorized by now. If not, pause the video, do what you need to do to memorize them, try flashcards, and substitute all of our values. I know we already knew cosine, we were given that, but we're just plugging everything in. Everything's okay. And notice I did put the negatives in front because I think they look better there in fractions. But we have two denominators with square roots in the bottom, and depending upon your homework platform or your professor, you will be expected to rationalize these. Although I'm not putting all the details in the slide, I'll describe them. If we multiply both sides by the square root of 5, the square root of 5 will appear in the numerator. The square root of 25 will appear in the denominator, which of course is equal to just 5, yielding these results. So it's pretty straightforward. Take the information you know, use it to figure out the missing piece, in this case y, and then build all of your trig functions values. Now you try. Pause the video and try the following. Suppose theta is in quadrant 3 and sine of theta equals negative square root of 3 over 2. Find the values of the remaining trig functions. Pause the video, give it a try. All right, here's your fair warning. If you haven't paused the video yet, solutions in 3, 2, and 1.